Okay, good morning. I'm Stephen Cunha. I'm CEO and VP of Sales for MEN Micro Incorporated. We're headquartered in the Philadelphia, Pennsylvania area. As some of you know, we have a parent company in Nuremberg, Germany. Our company, for those of you who are not familiar with us, we specialize in very high quality, standards-based embedded computing hardware that's designed for harsh and safety and mission critical environments. So today I'm going to talk about an emerging technology or an emerging standard called Space CompactPCI Serial. As part of the presentation, I'm going to talk a little bit about CompactPCI Serial for the benefit of people who aren't too familiar with the technology, so I'm just going to touch on it briefly. Then get into Space CompactPCI Serial, what that is, and then talk a little bit about conduction cooling technology, which is something that's common to both. It's common to CompactPCI Serial, and this conduction cooled technology that I'm going to briefly talk about is also going to be integral to the Space CompactPCI Serial standard. So just before I get started on the presentation, I was thinking my daughter in her 7th grade class last year, just stepping back and taking a look at our investments in space, she was required to write a position paper on whether or not we should reboot, in terms of investment, the NASA program, whether we should increase the funding again. And she really wrestled with that, and she was required, and her classmates were required to do a lot of research on that and look at the pluses and minuses. And she ended up voting in favor or taking the position that yes, we should increase or reboot the investment in NASA, largely based on the benefits that she discovered we've enjoyed here on Earth based on our investment in the past in space. So that was interesting, and it got me thinking about applications that involve some embedded technologies that benefit us here in a unique way on Earth. This is one. I'll actually show you a little more about this in a few slides later. This is an application, the first deployment is going to be in Australia, and believe it or not, it's with Lockheed Martin, with a rail group in Lockheed Martin. It's the ARTC Advanced Train Management System. It's not yet deployed, but basically what it does is it makes trains, I think both freight and regular passenger trains, more safe for people. It also optimizes the tracks, so it optimizes the use of the tracks in Australia, which is very important. But it's an interesting technology because it utilizes satellite technology to help make trains more safe. It's a technology that will enable someone in a remote office in Australia. There'll probably be only 3 base stations or remote offices to override the conductor and take over the train if 2 trains are getting ready to collide. So it's just an interesting, without the investment in space, this is just one interesting example of how we benefit here on Earth. And by the way, there is some embedded standards-based technology that's involved in this project. Not yet in the satellite, but I'll talk about that in a few minutes. Just talking about CompactPCI in general, just wanted to throw out a little bit the legacy that CompactPCI, I think John had mentioned this yesterday, the legacy that CompactPCI technology has had in space. It's interesting. And it also highlights the fact, and I think sometimes this is overlooked, because I think CompactPCI started largely as an industrial and a telecom standard, wasn't known as much for its robustness, but it did adopt the IEEE 1101 standards, the mechanical standards. CompactPCI can be very robust. It can be used even in military applications. And this is one highlight of that. Maybe people are recognizing this from I didn't see the movie Martian, but I guess the one variant of a rover was in this movie, so I'm looking forward to seeing it. I don't think it's the Curiosity. This is the Curiosity. And what's interesting about this Mars rover Curiosity, and some of you are already probably aware of this, it's using CompactPCI technology for the 2 rover computational elements. So there's redundant computers that are the brains of the Curiosity, of this rover. And I believe BAE Systems is the one, so it wasn't a traditional embedded computing supplier that provided the hardware, but I think it's BAE Systems that created the computing boards based on CompactPCI technology that are used in the Mars rover, which is pretty cool. Another one, this is the International Space Station. Some of you probably recognize this. This is also using CompactPCI technology to perform scientific tasks. So just the point is, CompactPCI, there are other standards as well that have a legacy in space, but CompactPCI technology in general has a strong legacy in space. So talk briefly about what is CompactPCI Serial. So just to give you an overview for some people who aren't aware, It's analogous to the transition that happened from VME to VPX. To be able to take advantage of the technology of the newer chipsets and the newer and higher performing technology. So I'll go into that briefly. In a nutshell, I guess the most fundamental thing is CompactPCI Serial. It extends the life of the CompactPCI standard because Serial has the same mechanical footprint and mechanics as CompactPCI. So you can actually put CompactPCI Serial cards in the same shelf with a traditional CompactPCI board in a hybrid system. So there is some backwards compatibility. But in a nutshell, it basically takes that parallel PCI bus that was in standard CompactPCI or CompactPCI 2.0. It takes it out of the backplane and it replaces the parallel PCI bus with all modern serial buses. I guess this is similar to VPX. So it's the interconnects here would be USB 2.0 and 3.0. You've got SATA in the backplane. PCI Express, of course, and then those are all, pardon? Yeah. So those are all available. Those three are available in a star interconnect, and then you have a full mesh capability with Ethernet in the backplane. So it's full mesh for Ethernet and a star capability for those other interconnects. What's nice about it is they're all available simultaneously in the backplane. So it's not either or. You have to choose one USB and then you lose out on the SATA, or you choose Ethernet and you lose out on PCI Express. In the backplane, they're all available concurrently. You can choose whether or not to populate the connectors in the backplane depending on your application. So some customers will save money by not taking advantage of some of the interconnects that are in the backplane because the connectors, I mean, that adds cost basically. So again, it's using the existing Eurocard mechanics. This is just a graphic of what I was mentioning earlier. You've got the simple star architecture for PCI Express, SATA and USB combined with the complete mesh for Ethernet in the backplane. The connector, by the way, I think it's 178 pins, twisted pair, up to 12 gigabits per second speeds in the backplane. This one thing that's very nice about this architecture and makes it useful for spaces beyond military and aero is that it's very simple architecture. It functions, you can use it without any switching or bridging. And this is maybe a relatively minor thing, but one thing that's nice about CompactPCI Serial also is that the header connector now is on the board or the plug-in module instead of on the backplane. When the header connector was on the backplane, I think maybe some people are aware you'd have bent pins in the backplane, and it wasn't very serviceable. When you had a bent pin in the backplane, you had to go basically forklift, change the whole thing. CompactPCI Serial kind of moved in the direction of VME, which has the header connector on the plug-in module or the boards. So just going to click through a couple of quick examples to show you how CompactPCI Serial is being used in real-world applications. Two of them are train applications, but the third one is more an oil and gas one. This is that Lockheed Martin application I mentioned earlier. The box that you see in the upper right-hand corner is basically a safety-critical box. It's not sitting in the train, but it's sitting in the base stations. So it'd be sitting in 3 different base stations. It's got both a safety or a vital side, and then it's partitioned so that there's a non-vital piece to that platform. That is based on CompactPCI and CompactPCI Serial technology, and that is the box the box that's being used to basically take over the trains in case 2 trains in Australia. It's not implemented yet, but when it's implemented, we'll take over from the conductor and stop 2 trains from colliding. It's certifiable up to SIL level 4. VxWorks was used in this particular application, but it's also capable, some of the same technology in that box, in that system, can be certified up to DAL level A for avionics. In fact, one of the key elements in that platform has been certified up to DAL level A for avionics. Next application, this is another way CompactPCI Serial is being used. This is in trains. This is actually in the United States. This is for safe train control. I cannot mention the name of the customer or get into any more detail about the application, but that is a conduction-cooled box. And what's interesting about the railway standards in the US or North America compared to the European standards is the standards, the ARIMA standard and the AAR standards largely seem to make use of military-type standards. So that's why the box that you're looking at looks a lot like a military box. It's being used inside of trains for safe train control. Oil and gas, so this is a customer this is a conduction cooled box, also based on CompactPCI Serial. The boards in this case are stacked vertically instead of horizontally. You can see there's some industrialization on the box because this customer really cared about the look and feel of how the box needed to look for their customers, which are the oil rigs. So that's why you see some orange feet and some orange handles on there. But it's basically a conduction cooled CompactPCI Serial based system. By the way, this is actually using satellite technology as well. So it's collecting data at the oil rigs in real time, sending it via satellite to a remote office where the data is being analyzed. One of the key applications there is just to optimize the drilling in the field. So unfortunately, as you know, this market's a little bit depressed right now, but it's an interesting application. Okay, so wanted to get into what is Space CompactPCI Serial. Hopefully that was enough background to talk about what would be the extension. Basically, Space CompactPCI Serial is going to be an extension of CompactPCI Serial standard. Wanted to share briefly the impetus behind Space CompactPCI Serial. I think we're all aware that there's already Space VPX, which I'm sure has its place. There may be some other standards in outer space, or for space, that I'm not aware of. But basically, the impetus or the thing that initiated Space CompactPCI Serial is a large project that Airbus Defence and Space won with OneWeb. It's a big contract with OneWeb. I think one of the investors for OneWeb is Branson from Virgin Airlines. Is that his name, Richard Branson? Basically, the contract has been secured by Airbus. It's to build 900 satellites. 700 will be basically circling the globe, and 200 are for spares. It's a nice business opportunity for the embedded space. It's basically going to provide very high-speed internet access for people on Earth around the globe. The goal is to have the first orbiting fleet in 2018. So the time to market pressure is high. You can see they need to build 4 per day of the satellites. The size is that little box there is sort of an image of what the satellite's going to look like, but it weighs about 330 pounds. It needs to be less than 330 pounds, and it's going to come up to the size of somebody's hip, basically. So it's a small box. Because it's a private thing. There's a lot of cost pressure, and of course there's time to market pressure. The challenge for somebody like Airbus to really start to to be able to meet the cost targets and the time to market targets are the current architecture inside of satellites. So it's mainly right now a federated avionics architecture where you have for each individual function, and some of these functions are listed here, like orbit control, satellite attitude. Each function has a dedicated box. So it's very expensive, and it adds weight to the satellite every time you want to add a function. That's a challenge. Each computer system uses a different OS. If you need to achieve high availability, that adds complexity to your development cycle. And it's operating with many different buses and interconnects. So it just makes it right now the existing way that the architecture is done in satellites makes it very difficult to get to market quickly with new satellites in a costly way, in a low-cost way. So I just wanted to share how the challenges are being addressed, and this ties into Space CompactPCI Serial. The goal, Airbus has developed a consortium. Currently, it's all European-based companies. There's a consortium that's working on replacing this federated avionics architecture with an integrated modular architecture for avionics architecture called IMA. The idea is you have instead of having each function sitting on a dedicated computing platform, you have multiple functions working off of the same computer, or a common computing platform that can be leveraged for more than one function. This consortium, it's kind of a mouthful, but I'll say it's Open Modular Avionics Architecture for Space Applications, OMAC4S. It's a consortium. And one of the things the consortium has done, they've decided to, they looked at the standards available on the market, they looked at doing things in-house, they decided to use CompactPCI Serial technology as the foundation or basis for the satellites they're going to build. And so that's why the Space CompactPCI Serial working group started. The main things that you would address with the extension to CompactPCI Serial are somebody mentioned it earlier, availability is one big thing. And the thing with availability, I was thinking of a quote that I saw on the internet from, I think his name's Scott Doyle. He was a systems engineer, or he is, with BAE Systems. He said, there's no repairman in space. That's that's one of the reasons you need availability in these satellites. You don't have the ability to be servicing these boxes very often. The other issue somebody also mentioned is cosmic radiation. You want redundancy and availability so that if electronics are affected by cosmic radiation, you have another computer that's able to take over for a short period of time. So anyway, that's one thing. And then support for the serial interconnections that are sitting in satellites right now. That's the other big thing that the extension will address. So just feeling a little warm. Okay, so the next, why did they choose CompactPCI Serial for space? I won't go through all of the bullet points, but the main thing for Airbus was the simplicity of the CompactPCI Serial architecture for reduced cost. It's just a simpler architecture to work with for time to market and reduce cost than what they saw available on the market. CompactPCI Serial is a highly defined standard. I don't want to say rigidly defined because that sounds bad, but it is very, very rigidly defined for the pinouts, which makes it easier to have interoperability. Everything, all the systems, the peripheral slots in a CompactPCI Serial backplane are the same. The pinouts are the same. It's very easy. It's not always great for companies like us, but you can replace one vendor's card very easily with another one, which reduces costs, gives Airbus a better cost and more choice. CompactPCI Serial, and I'll mention this toward the end of the presentation, already supports in its standard conduction-cooled technology in a low-cost, also simple way. It's basically cost optimized, and CompactPCI Serial is able to address, especially with the conduction-cooled wrapping around it, address the traditional challenges of space, like the harsh environment, the takeoff, all of that kind of thing. So those are the main reasons. But the basic reason for Airbus to choose CompactPCI Serial is cost and the simplicity of the architecture. And it doesn't sacrifice anything in terms of the robustness compared to other standards. I just highlighted, I don't know if, the other thing that they said is, and this is from a white paper produced by this consortium, they said CompactPCI Serial has extremely high bandwidth because of the high density of pins, and it's a very high bandwidth. And then they wrote in their white paper, proven Eurocard mechanics and conduction cooling capability make CompactPCI Serial an ideal solution for low and moderate cost, modular, mission critical, and aeronautics applications. So that's kind of why they chose that technology. What is it briefly? I'm not going to go into a lot of detail, but it's basically the extension. By the way, so I just want to say we're looking for people in the US to join this working group. This is still a proposal, but it needs to move very quickly. As you see that they have to deploy these satellites in 2018, but it would be good to have people from the US involved in this working group, and we're recruiting people. So anybody is invited if they want to make a contribution to this standard. But two of the basic things would be creating a switch fabric slot, defining a switch fabric slot, defining a node slot, and then defining the overall hierarchy of how the master controller slot, the I/O slots, and these two new slots would fit together, basically, if that makes sense. The last thing I'll mention today is just conduction-cooled technology, like how does this apply to, these are basically, as you see here, there's a bunch of requirements that are needed for space in those red boxes. But how does how does MEN implement conduction-cooled technology in a way that was attractive to, or not MEN, the standard, in a way that was attractive to Airbus? So I'll talk briefly about that. And sorry. All right, I'm almost done. So just briefly, I'm just going to say, because for conduction cooling, it is integral to the CompactPCI Serial standard, and the way that it's done in CompactPCI Serial, you don't touch the layout of the board. So basically, the traditional approach for conduction cooling is you would put fillers inside of the board. You might touch the PCB or the layout of the board. It adds cost. It makes it more customized. For CompactPCI Serial, it's integrated into the standard that you basically wrap a cartridge. Each cartridge needs to be unique and take the hot points from the board and the hot components. But you wrap a cartridge around the same air-cooled card that could be used in an industrial automation application or an oil and gas application. And that's part of the standard, and that is something that's going to be brought forward for a Space CompactPCI Serial. So basically, one thing that's very nice about that is you can have the same air-cooled Intel i7 card that's 3U CompactPCI Serial based, and it could be leveraged in the mil aerospace with a conduction-cooled wrapping, but you can take that same underlying PCB with the components and use it for an industrial automation application or a medical robotics application. Gives you a chance to take advantage of economies of scale. So it's lower cost and it's a simpler way to do conduction cooling, and that also was attractive to this consortium. So the last thing I'll just wrap up with is, I don't have, that's kind of shows how, what an air-cooled card looks like, and then this was what it looks like with conduction cooling around it, and again, the layout of the PCB is not touched. I'll just write, you can do the same thing at the system level. Again, I just wanted to share, we think it's very exciting, Space CompactPCI Serial technology. And I think there's going to be more opportunities beyond this OneWeb opportunity. So anybody is invited to join the working group. Now is the time, because they're going to need to move quickly. Thank you.